This is a UTME physics problem. Even though this question is not properly worded, but let's solve it regardless. The question says that a stream is flowing at the rate of 0.75 meters per second, and a boat heading perpendicular for the stream landed at the opposite bank at an angle of 30 degrees. Calculate the velocity of the boat. Now, there are two velocities that this boat have. There's a velocity such that, so let's draw the stream. So let us say that this is the stream. So this is the stream. And we can put a direction such that the stream is flowing in this direction, and the rate at which it is flowing is 0.75 meters per second. Now, if this stream is not flowing like this, if this stream is just still, and then the boat that is heading perpendicular, so the way the boat would have moved is such that, so the boat could have moved perpendicularly straight like this. So there is a velocity in still. So let me call this one normal velocity. So that is without any effect of anything on it, the boat would have headed this way. But because this stream is flowing and is flowing in this direction, so there will be a combination of the normal way that this guy can move, the boat can move, and also the contribution of the stream as well. And then what that would take the boat not to land exactly here, but rather the boat will have to land here, somewhere here. Now, this is also a velocity of the boat, but what do we call this one? It is the resultant velocity of the boat. Is the resultant velocity of the boat due to the effect of number one, its own velocity and the velocity of the stream. And according to the question, this landing took place at 30 degrees. So 30 degrees deviating away from the normal place where it's supposed to move. So this is the right, so the question saying that calculate the velocity of the boat should have stated whether it is the velocity of the boat, the resultant velocity of the boat, or the normal velocity of the boat if it was going to move perpendicularly. So, but according to this question, what they want us to calculate is the resultant velocity of the boat. So basically, we know that the stream is flowing in this direction. So we can just put that. So for the boat, we have this, and it's going in this direction, which is 0.75 meters per second. So what we need to do here is that we are looking for the hypotenuse. This is 30 degrees. We have the opposite. So we can use sine, because we know that sine theta is opposite divided by the hypotenuse. So which implies that sine 30 degrees equals, the opposite is 0.75, and then the resultant, which is what we're looking for, the resulting velocity. So that implies that VR equals 0.75 divided by sine 30 degrees. And what would that give us? That would give us 1.5 meters per second. So that implies that the resulting velocity of the boat, based on the effect of the stream on it, is going to be 1.5 meters per second. So if you like this video and you want to see more of it, subscribe, like, and share. I'll see you in the next one.